and go. Hello, everyone, and welcome to PHP Dublin June. Have a special one this week. We have Larry Garfield talking about never use arrays, wink, and he is going to be talking about a subject that we're all aware of in PHP land, arrays, the do's and don'ts, and the pain. So just to give everyone a heads up of what to expect, we are going to have a 50 to 55-minute talk, and then we're going to have a Q&A session, which will go on for as long as everyone has questions and would like them answered. So I would like everyone to enter their questions into the chat on YouTube, and then at the end of the talk, I will address the questions to Larry, and if you have any thoughts, any comments, any smart-ass sarcastic quips, put them into the chat as well. The people you know who I'm talking to, you know you're going to do it. So yeah, without further ado, I'll hand it over to Larry. Larry, welcome.
Hello, hello. Yeah, good to see Dublin again, in a manner of speaking. So we're going to be talking about arrays tonight. I'll try to make this an exciting topic. If you'd like to follow along at home, I just dropped a link to the slides in the YouTube chat. They're not actively linking, but you can copy and paste it. As mentioned, my name is Larry Garfield. You may know me online as Krell. If you want to make fun of me during this talk on Twitter, that's where you do so. I generally encourage it. I am a staff engineer for Typo3. My full-time job is working on Typo3 core now. I'm also a member of the PHP Fig core committee. If you're not familiar with that, Fig is kind of like the United Nations of PHP with all the good and bad implications that has. I've gotten more involved in PHP internals in the last year or so, and I've mostly been editing RFCs for code that other people are writing. And I also have a couple of books out in PHP, most notably Thinking Functionally in PHP. Yes, functional programming in PHP is a thing. It does work. And we're going to give away a copy of that book at the end of the talk, so stick around. We're going to have a raffle. As well as Exploring PHP 8, which is free. If you are still haven't been exposed to the amazingness that is PHP 8, this is the most detailed and entertaining changelog you have ever read. Both available on LeanPub. But enough of that. So let's talk about arrays. Arrays are the iconic PHP-ism. PHP loves its arrays. Most code bases have arrays everywhere. You can recognize a PHP developer by the fact that they use arrays so much. PHP's standard library has more than 80 functions that are just there to help manipulate arrays in various fashions. But that's not actually good because they come with an array of problems. Yes, the jokes are going to be that bad tonight, fair warning. What kind of problems do I mean? Well, their behavior is actually very inconsistent. They don't behave the way you expect they behave. They provide no type safety at all, as in you don't know that things in the array are of the same type. They could be, or they could not be. You have no way of telling. Their error handling is basically non-existent. Their performance is quite terrible, in fact. This is not necessarily true in other languages, but in PHP, arrays performances are really quite awful. And the biggest problem, of course, is that PHP doesn't have them. So none of you are using arrays in PHP. What? Okay, before I continue, we do need to address the elephant in the room. I warned you. So what exactly do we mean by an array? Well, in standard programming language speak, an array means an ordered sequence of values of the same type identified by an offset. Ordered sequence of values identified by an offset of the same type. This is not what PHP has. This is what most languages have, but this does not exist in PHP. What PHP has is associative arrays. Associative arrays are an arbitrary key value index that maintains an order. In most other languages, this is called a dictionary, like Python, or a map in Go or in Rust. numeric keys in PHP are handled via a hack. When you assign a key, it may get mutated. If you don't assign a key, it gets generated, but it's still a key. It's not an offset. And they're not type safe either. You can have an int or a string for a key. If you pass a float, it will automatically get silently rounded down to the nearest integer and saved as an integer, which is frequently not actually good. So this is terrible. Where does this run into a problem? Let's have an example. We have an array, we push two values into it, we print the results, cool, we get what we expect, two values with keys 0 and 1. Now let's unset a value and push another value onto that list. Now what's the result? Oh, look, there's now a hole. Why is there a hole? Because the double bracket operator does not mean add to array. It means look up the internal counter in the array structure in C, or in the engine, increment that by 1, and use that as the new key. It's make up a key for me based on a counter, not put things in, not actually build a real list. And this is a huge problem as soon as you try to do something as basic as a for loop. Because if we try to for loop over that array, what happens? We get an undefined offset error because I will take the value 0, then 1, then 2, but 1 doesn't exist. So for loops are unreliable in PHP because of arrays. Because you cannot trust that AI will exist. AI is a threat to your code, which if you've been paying attention to the news recently, you already know. Here's another example. This is real code out of a real open source system. It's part of the SQL abstraction layer. What it does is take a query string and list of arguments, like a prepared statements. And if one of the arguments to replace is an array, then it expands the placeholder in the query string to be multiple values. So you can say, where in foo, and then pass an array for foo, and it will turn it into a series of separate placeholders. Nice functionality. It's good functionality to have. But what happens in this code if data there, that subarray, has string keys instead of numeric keys? Oh, look, and an SQL injection. That's what happens. Because then you get that string concatenated with the key name, and that gets placed into the query string unescaped, and boom. This is the bug behind Drupalageddon, the worst security hole in Drupal history, because that, combined with another bug in the array-based form API, meant that they combined to allow a remote arbitrary SQL injection for anonymous users. That is also known as a oh holy crap level bug. The fix for it was very simple. Just renormalize that array to be a numeric array starting at 0 with no gaps and definitely no strings for keys. But still, that was an error that should not have been possible to write in the first place. The fundamental problem is that PHP uses arrays in place of purpose-built data structures. And that is almost never what you want. Almost never is using an anonymous informal data structure the correct answer. So what is the correct answer? Having a real purpose-built data structure. That's what you should be doing instead of the cheap anonymous ad hoc version. What does that look like? Let's look at some examples. We're going to start with lists. Arrays can work for your trivial case. This is, when you actually do want a sequential list, keys are not relevant. You just want them to be integers. Arrays can work here in trivial cases, but they break down very quickly. We just saw two very good examples of where using an array is going to bite you. So what can we use instead? Well, PHP has this thing called array object. And when we say data structure in PHP, what we generally mean is classes and objects. That's what data structure ends up meaning in PHP specifically. Array object is a built-in object in PHP that implements countable, traversable, and array access. So it works and can get used almost like an array. It's not, but it's sort of an array. But as an object, we can extend it with, say, a typed array class that looks like this. We hide the constructor on line 10 and make that internal only. And then the only way to construct this object is using a for-type static method that we create that requires a type be passed in. And we make a new instance of this object and save that type onto it. And then when we go to set a value on this object with offset set, that's what gets used for the array access when you try to set something, we check, all right, is the value being passed in one of the value or one of the types that we support? If not, throw a type error. We're done. You're doing it wrong. If it is, cool, do what you would normally do. Which means we can now create a typed array for a certain class, in this case, point, and then we can populate it with point objects, which means when we then go to for each over this array object, we know, guaranteed, every value of point inside that for each loop is a point object. If it weren't, it would have errored out already. If we try to put something else in there, like a different object or a string or whatever, we'll get an error. And we'll get an error exactly where the actual bug is of passing in the wrong type. This is cool, but we can do better. What if we don't want to allow string keys? We want to ensure just a sequential list. All right, we can just make our own object then. We have a typed sequence here. We're going to implement countable, so we have a count method, and iterator aggregate, so we can for each over it. When we do the same hidden constructor and for type trick as before, nothing changes there. The count method just counts an internal array of values. Get iterator returns an array iterator of that array. And we have an add method to add things to this object, which does the same check as before. If the value is of the type we want, cool, add it. If not, toss, throw an error. Note, there is an array used internally here. That's okay. You can't have an arbitrary length list of values without using an array in PHP. But that array is a hidden implementation detail. The actual API is strictly this method, and there is no way for the API to allow an invalid value to be put into this list. So we can now call add with whatever value we want, as long as it's of the type that we've specified, and then iterate over this object, and for each will give us back values as we expect. And if you need other methods beyond just add, like a has method or whatever, you can add those. You can add whatever methods make sense for your use case. Now, at this point, I'm sure there's someone here who is going to point out that arrays pass by value and objects pass by reference. Therefore, this is not truly a substitute for arrays. And I will say you are incorrect, because objects do pass by value. You have been lied to. And that person will point out, and I'm sure this person knows who they are, but if you modify an object once it's passed to a method, that does modify the original object. But that is not because they are passing by reference. They're passing a handle to the object by value. So you now have two handle values that point to the same object in memory. And yes, this is somewhat confusing. Deal with it. Point being that, yes, it's true if you pass an object, if you pass an array to a method and modify it in that method or in that function, then that change does not propagate elsewhere. If you pass an object, that change will propagate. This is not ideal. You want to have immutable values. You don't want spooky action at a distance, but we can fix that ourselves. If we want to have an immutable typed sequence, then It's basically the same thing, except now when we go to add a value, instead of just adding it to this object, we'll clone the object and give the new object a new list of values that's the same ones as this object plus the new one, and return that new object instead. That way, this object doesn't change. You get back a new object that is what you had asked for. If you want to remove a value, then same idea. We check and see if the value being removed is in this object. If it's not, just return it as is, we're done. If it is, then clone the object and give it a new list of values that are the same as the old list minus whatever we're removing, and call array values to reindex that list. So we're guaranteed that the internal values array here is always a packed array with keys that are integers starting at 0 and incrementing by 1. We're reindexing it so that we always get back something that simulates a straight list, a linear list. This is actually fairly efficient in PHP. In most languages, you would have to do some extra work here to make sure you don't end up duplicating tons and tons of memory. PHP natively does copy on write. So most values are not actually duplicated unless they have to be. So this is surprisingly memory efficient in PHP compared to most other languages. Yeah, there are probably some edge cases where it's worth it to do something else, but for the most common cases, this is sufficiently memory efficient. You don't need to worry about it. Cool. So now we can pass this object around to wherever and rely on it not changing out from under us. That's a good thing. We can also, at this point, though, very easily just make a version that's specific for our type by getting rid of that for type logic and just type declaring our parameters to begin with. This is easy enough to do for any class you have. You can make one for primitives too if you really care, but usually I want objects anyway, as we'll see. And so now I have an object that is a list of some other type of object, and the type system takes care of all of that checking for me, and it's immutable. Cool. What if we care about uniqueness, though? This code won't check for uniqueness. All right, let's check for uniqueness. We'll make a set, which does the exact same thing, except we'll break out that has logic to its own method instead of putting it in remove, and then use that has method in the add method as well. So if the value is already there, cool, don't re-add it, just return the object as is. If it's not already there, add it, we're done. This guarantees we have unique values. Arguably, I shouldn't be using inheritance here. I should be using something else, but this is short and fits on a slide, so good enough. Maybe we care about the order. Okay, let's extend that set. So now we have a ordered set, unique values, that takes a type and a comparison function. And that comparison function we save. And then when we go to iterate the object, we first sort all of the values that we've saved based on whatever that comparison function is. So a caller doesn't have to think about remembering to order things. They just throw values in and it comes back ordered. In this example, we're going to create a comparison function for points, and we'll sort them first by their X value and then by their Y value. We're going to use the spaceship operator for sorting and PHP 7.4's short lambdas because they're cool. Then we create an ordered set for type point with this comparison. We add a couple of points to it, and then we just for each over the set, and we get back those points in the order that we had specified according to that comparison function. As the caller, I don't need to worry about that. It just kind of happens for me. That's cool. I don't have to think about something anymore. At this point, though, honestly, the comparison function is a bit wonky to have to write this way, so let's just internalize it. We'll have a point set that is specific to point objects, and we'll do the same kind of uniqueness logic as before with a has method, an add method, and a remove. We'll let the type system do all of our checking, so we only get point objects, and we'll just put the comparison method inside the class where it's easy to maintain, and then we call that in the iterator. Nice. What have we gained by doing this over using just arrays? We get type-safe lists. We get lists of values where we can guarantee syntactically what type of values we have. We can get a list that we can guarantee is a sequence. There's no holes in it. All the keys are sequential integers. If we want to guarantee that something is immutable, we can very easily do so. We get a much more self-documenting API. We have add, remove, has. If we want to have other methods that make sense on points, but don't make sense on products, we can easily do that. This means we can encapsulate functionality into objects that are part of our domain model. By wrapping technically there's an array storage underneath, but by wrapping that into a simple class, we can build a real true part of our domain model in which we can put whatever functionality makes sense in our use case. And this is not difficult. Once you realize that you can do so, every one of the examples I just showed took me less than 10 minutes to write. All but one of them took me less than 5 minutes to write. You can spare 5 minutes to get all of these benefits? Yeah, do that. Now, there is one additional caveat, though, in that objects, if you type hint something as an array, well, you can't pass an object to it anymore, an iterable object. So does that mean we can't type hint on arrays? Well, yes, it's kind of sad, but there are ways around that. There's really two cases to consider here. And it comes down to whether or not we care about the type of the objects. If you want to type a method or a function or a parameter to say, I have to have a list of products, all right, then just make an object for that. It's now a real typed collection. It's part of your domain model. It's part of your API, and you can build whatever functionality makes sense onto that. And then type against that. Cool, I get a list of products, done. Other times, all you care about is that you can for each something. The something doesn't matter as much as the fact that you're going to for each it. In that case, what you want is iterable. Iterable is a pseudotype added in PHP 7.1 that is the union of array and traversable, which means either an array or an object. Iterable roughly translates to for eachable. You can think of it that way. Traversable is an interface that is only ever implemented by iterator or iterator aggregate. And the most important iterator is a generator. I love generators. Generators are fantastic. A generator is a function that lets you generate a lazy stream of values. And you can generate that stream of values however you want, including making the values themselves lazily. So this can save memory. It's great for flattening a structure. Say if you want to walk a tree in a certain order, then you generate and yield each value or each node in the tree one by one, and it comes out as a linear list. This leads to much simpler code in many cases because you don't need to prepare or pre-create an array of whatever it is. You can just yield values as you walk it. As an example, let's look at PSR 14. PSR 14 is the PHP Fig event dispatcher library specification. It's used by most major systems at this point. One particular part of the spec has a method called get listeners for event. You pass it an event object, you get back a list of listeners, which are functions or methods that you're going to call with that event to let them do stuff. We tag or we type the return for that method as iterable because we don't care if it's an array or a generator or something else. All we care about is that we can for each over it and get a bunch of listeners out of it, a bunch of callables out of it. So that's all we tag it as. The minimal requirement we have is that we can for each it. The dispatcher that uses that method is pretty much always going to look like this. For each get listeners for event as listener, call the listener with the event. And that's about it. Which means we can have very basic providers that will just return an array of callables, or we can have more complex ones like this. This is an example out of Tsukio, which is the PSR14 reference implementation that I maintain. It's a nice little library. Don't worry about the specific details here. The basic idea here is simply we're introspecting the object that's passed in, the event, and based on that and values it has, and if it has a certain interface and other stuff and methods exist, we are creating a callable on the fly on line 14 and yielding that. So we never have an array of callables. We just generate them on the fly and return them, which to the dispatcher on the previous slide is fine. It just gets back a stream of them and it does what it wants to do. This makes it trivial to stitch these together as well. If you want to concatenate a series of providers, they're just returning iterables. So you have a provider that implements the same interface and wraps an array of providers that implement that interface. And when you call it, it simply yields from each of those. Yield from me is basically shorthand for each that value yield each item. So it just flattens the array there. It doesn't matter if the inner provider is returning an array or a generator or anything else. As long as it's an iterable, that's all we care about. And this is in the Event Dispatcher utility library published by the FIG. So go ahead and use this in your own projects as is. It works great. Of course, generators are not compatible with that huge library of array functions that PHP has. But so what? How often do you use them? Really, not often. I don't use the vast majority of them the vast majority of time. If you have a use for them, they're still valid as an internal implementation detail. We have that array inside these domain objects, and we can call those array functions on that. That's fine. If you really need them, though, most of them are very easy to re-implement. So the fact that they're in core in the standard library is more of a historical artifact than because it makes sense to. Far and away, the most common ones I use are array map and array filter, which don't work on iterables. Okay, here's versions that work on iterables. Map just for each over them and yield, so it stays lazy, operation on that value. Filter, just yield the value if it matches a filter. If you need others, you can re-implement them, but in practice, this is enough for most of what I do. A number of frameworks have collection libraries that try to build a lot of this functionality onto a generic object. And that works, but you don't really need a large library for it. In fact, let's write our own right here. We're going to make a collection object that is completely lazy and immutable and supports map and filter. So we'll create a collection object. It's going to implement iterator aggregate. We're going to hide the constructor again and offer two ways to create a collection. Either provide a generator, and that generator will just save, or give it an iterable, could be an array, could be a database result, could be anything. And we'll save that by calling from generator with a new generator function that just yields from that iterator. So we convert an iterator to a generator that way. Very simple. And then when you go to iterate this collection, we'll just invoke the generator and return the iterable that results, and for each can handle that just fine. To add values to it, we can have append, which takes a list of iterables. Thank you, Variatics. And returns a new collection that has a generator that will itself yield from this object's generator first, and then yield from each of the new collections, the new iterables in turn. So this is the same appending concatenation logic we saw a moment ago, just all wrapped up in generators. And if we want to add individual items, well, adding a list of items that on line 12 there, that comes back as an array, which is iterable. So we just append, because one is a special case of many. Then we want to take action, do operations on it. So we have a map method that will return another collection object with a generator, which will simply apply that same map logic we saw, the for each loop, and yield each item. So it stays lazy. And then we can have a toArray method. So at the end, we can just say, all right, flatten this all out to an array now. Or we could have a reduce method that does a reduce logic on it, or a fold logic, and produces a single value at the end, or whatever else we want. If you want to add filtering, cool, that's easy enough to add as well. And then using it becomes really simple. We create a new collection from an iterable, pass it some iterable of some kind. In this case, it's an array. Add a couple more values to it, map it. Each time we're creating a new C object. And then when we go to print it, print to array, we get back what we expect. 1, 2, 3, 4, 5, 6 times 10. This whole thing took less than 60 lines of code, including white space. That complete, lazy, immutable collection object was less than 60 lines of code. More robust libraries exist that do essentially the same thing. Maybe they have more options for lazy or not lazy or whatever. The point here is not that you should use this code. You probably shouldn't use this code exactly as is. Point is, adding this functionality, laziness, map and filter, whatever, to your own domain objects is really simple. Once you realize how simple it is, you can just bang that out in a moment. Maybe throw in a trait or two if you want to get really dry about it, but building purpose-built domain objects that do all of this stuff for you is easy and doesn't require a ton of work, doesn't require a ton of code, doesn't require big libraries, doesn't even require doing much inheritance, frankly. So just write the code you need. It's easy to do. What about associative arrays, though? I mean, that's the other half of PHP's array handling, are associative arrays. And there's really two different kinds of associative arrays we have to think about: lookup tables and anonymous structs. These are different use cases that PHP uses associative arrays for both, typically. Lookup tables are a map from an arbitrary value to an arbitrary value. Order generally doesn't matter. The keys are going to be instant strings. This is commonly used when the keys are not known at code time. They're going to be based on configuration or user data or something you pull from a database or whatever. You can't just hard code them in advance. So we get, patterns like this that appear a lot, where we have some routine that gets a list of builder objects, and we build a lookup table on the fly, mapping from the format that the builder takes to that builder. Cool. And then we use that lookup table, pass in a value and say, all right, get me back the appropriate object. And then I call build output on it, and we're great. Problem: there's no error handling in this anywhere. What happens if there's a missing key? If that accept header that we're passing in doesn't match one of the builders we have? Are we guaranteed that what we're going to get back is in fact an object that has a build output method on it? It's not guaranteed here at all. So what can we do instead to fix that problem? Well, let's start by building our own lookup utility. To keep the syntax similar, we'll use array access. Cool. And we'll use the same for type trick we as before, but we're also going to save a default value. And then on offset set, we ensure that the offset is a string. So we're going to not allow numeric keys here. And ensure that the type, that the object is of the type we specify. And then on offset get, if the value is, if there's a matching value, use that. Otherwise, return the default. And then offset exists and offset unset are boring. Now we've internalized all the error handling. So we can create a lookup table for output builder objects specifically and provided the default. Then we populate it the same way. And now when we call lookup with a value, we are guaranteed to get back an object of type output builder. It might be the default, but we're guaranteed to get back an object of the type we want. Of course, array access is actually a little slow, and this is not necessarily clear code because it's still looking like an array, even though it isn't, which is weird. So, all right, let's not use array access. We'll just create a lookup class, save a type and the values, same for type logic as before. This time, though, we're going to provide the default on lookup instead of on creation. Which one is better? Neither. Take your pick. Both have perfectly good use cases. Do whichever one is, fits your use case better. But at this point, though, it's simple enough. We might as well just make it specific for our use case and turn it around. So now let's have a builder map service that it takes the builder provider and a default format to use. And it has a lookup method that will lazily build the internal array of objects, an internal lookup table on demand. And then when it's called, it'll say, all right, return the value that matches the key if found. If not, return whatever matches the default value. Everything here is now type checked. Using it is trivial. We don't even need to think about the lookup table. We just ask the map, hey, give me the appropriate builder for this accept header. And you're guaranteed to get back a value of the right type that you can now use. In practice, you'll wire this up in your dependency injection container. This is now not code that belongs in your business logic. This is part of your service layer. This is now just logic you push back. So if you're doing this, build output stuff in your controller or something, guess what? We've now pushed that logic out of the controller where it does not belong into a service that we can test, we can verify, we can type check. More errors are now syntax errors. And so you cannot actually make that error. That's good. You want errors to be obvious syntax errors. This code is trivial. It's easier to read, but you now don't have to worry about all that error handling and second guessing and edge cases. It's all handled for you simply by using purpose-built data structures and a type system. How about anonymous structs? This is the case where keys are known and fixed at development time. If you worked in PHP any amount of time, you have almost certainly seen code like this at some point, where we have an order pseudo object, order record, whatever, and it's got some properties on it. But I don't know, is canceled spelled right? Does canceled have one L or two? Anyone actually know? Trick question. In UK English, it's two. In US English, it's both, because English. So is that the correct spelling? I don't know. I have no idea. Is user correct? Is it USR? Was this written by someone who's allergic to vowels? Or is that a typo? Is the user supposed to be an ID? Or is it a user object? I don't know. Are the SKUs there supposed to be numeric or strings? I mean, some of them are numeric, some of the strings. Is that legal, or is that a typo on my part? I don't know. Can it be a single value? Sometimes these objects, or these pseudo objects, will allow you to have a single value or an array, and it'll upcast for you. Is that going to happen here? I don't know. Are there other properties that we can have here as well? that are just omitted because they're optional? I don't know. What is total? Is that a currency? What currency is it in? Is that dollars? Is that euros? Is that pounds? I don't know. I can answer all of those questions by converting it to a class. We now know, oh, ID is a string, not an integer. We know that the user is supposed to be an object, and it's an object of type user, and it's spelled USER. So it was a typo before to not have the E. Money is an actual money object, good, and that will be enforced. We're using the UK spelling of cancelled with 2 L's, cool. We know that skews is not going to support individual values. It has to be a list. Might be nice to also specify, make that a list object of, skew list object rather than an array. But this is already 10 times better. And in PHP 8, we can take it even further and make it use constructor promotion. So we can now create one of these objects with named arguments that, in a constructor that will automatically become public properties of the object. This, for like 15 seconds of writing to write this, we now have all of those questions answered for us. And all of those things are now syntax errors if we get them wrong. And we don't need documentation. The code teaches us how to use it, because if we see an order object somewhere, we can just look at the class definition and we know exactly what the properties are. We know exactly what their default values are. We know exactly which ones are optional. We know exactly that there aren't others. We know their type. And if we get it wrong, we get an error immediately. Usually before we even run the code, because we're using an IDE that will check that for us, right? We all are? Good. Another example of this kind of pseudo object are options. This is a code smell. Options is the second worst variable name in coding, right behind data. No offense to the Android fans in the room. No Star Trek fans? All right. What are the possible values for options? I don't know. Which of them are required? I don't know. What's their spelling? US or UK or what? I don't know. What legal types are they? How strict is it? Is it going to accept a string versus an integer? I don't know the answer to anything here. Okay, well, documents, document stuff, right? All right, well, this is better. We now know it has a layout, a label, a BG color, twice. Documentation, right? Never keeps up. We're using US spelling of color as God intended. We have a font size in points. Okay, but as we said, documentation gets out of sync. And there are a lot of people who keep insisting that good code is self-documenting. And if you need to document it, then then it's wrong, and you need to do a better job of it. This is fair up to a point. I don't completely agree with that, but if you can eliminate documentation by putting it in code, you should. So what's self-documenting? Objects. Objects are self-documenting. We now know exactly what the properties are. We know their spelling. We know their default values. We know the ones that don't have a default are required. We know that there's no others. Just by switching from an array to a classed object, which again, in PHP 8, we can now use with constructor promotion and named arguments, we have answered all of those questions. We now know layout is the only required property, and we know what the defaults are for the others. But we can do better than that. An object has more than just properties. It also has methods. So now we can provide a static constructor that takes the one required argument, and then whatever else. In this case, we can use named arguments and variatics on it to make it very easy to work with. And that will just create a new formatter object for us. And we can add arbitrary other methods as well that make sense in our domain model. So we'll say we have a dark mode that is going to set some preset color and BG color, or we could have an invert that flips the color and BG color, or whatever else makes sense in your domain model. What makes sense in the domain model? I don't know, you tell me, it's your domain model. To this point though, why are we then building this object and passing it to a function to configure that function? Instead, let's just put that function on this object. And now we have an object that is a product formatter. This is a verb object, a doer object, that takes one required property, layout, has others as we need, has methods as we need that make sense in our domain model for whatever we decide our domain model needs. And when we're done configuring it, we call format with the product we want to format, and we get back the result. This is way easier to use. We create a product formatter, call some methods on it, call format with the product, we're done. We build a do object and then use the do object. If that object has dependencies, like it needs to leverage a theme system, for example, all right, spawn it off of whatever its dependency is. So you call get formatter. That will return a product formatter object for layout standard with the theme system pre-injected into it via whatever its constructor is. We don't deal with it directly, but I can now use it the same way, call whatever methods I want on it to configure it, and call format and get back the result I want. We have completely eliminated the array. There is no array in this. But by removing the array, we've realized how to turn the logic around and build a much more usable and self-documenting and flexible and powerful API. Removing the array has given us the excuse to build a real API for our task, which is formatting stuff. Big blob of array is not an API. This is an API. Of course, I'm using public properties here so far, and a lot of people are going to point out that public properties are terrible and evil, and I won't entirely disagree with you. In fact, in the past, I was one of those people. I have moderated a little bit on that more recently. I would say if it's a private object that's not part of your API, you're just passing data between internal parts of your system, go ahead and use the public properties. It's fine. Just document the class as being internal only, and then using constructor property promotion, it becomes trivial to build. If it's part of your public API, then yes, make it private or protected properties and put meaningful methods on it. Meaningful method does not mean get and set. Get and set are not meaningful methods. What is a meaningful method? Something that makes sense for your domain model. What makes sense in your domain model? You tell me, it's your domain model. What about performance though? Aren't objects big and slow and clunky and worse than arrays and so on? In some languages. This might have been true once upon a time in PHP 4, but it's not PHP 4 anymore. I hope. If you're still using PHP 4, please don't. So a couple of years ago, I ran some benchmarks. These were on PHP 7.2. So it's been a few years, but I don't think anything radical has changed in the array system since then. And what I do here is I just take a million items and make a list. So I make a list of a million items. Each item is an associative array containing junk data. And then I sort the array and then resort it again. Not because I care about the sorting, but this is just a convenient way to exercise the array and manipulate it multiple different times and see what happens. And then I have the same test code that uses standard class objects instead of an associative array, an object with public properties, an object with private properties that are accessed through methods, and an anonymous class that use public properties. And then do benchmarks on it, run multiple runs, average them out, and so on and so on and so on. And these are the results I got. An associative array ran in 9.4 seconds on my computer and used about a half gigabyte of memory. So that's our baseline to compare against. Using standard class instead took about 20% longer and use 9% or so more memory. Basically, there is no purpose to standard class anymore. You should stop using it. It has no value. The public property version ran a bit faster. It's about 12, 13% faster. And wow, half as much memory. Half. Did I say half as much memory? The version with private properties and methods was a bit slower, but again, half as much memory. The anonymous class was actually the fastest of them for whatever reason. And again, half as much memory. I expected there to be a difference. I did not expect it to be this big. This blew my mind that it was this huge of a difference. Why? The reasons are nerdy. It's down in the engine. Basically, when the engine sees an array, it doesn't know what's going to be in it, so it has to allocate the maximum possible memory just in case. With an object, it knows exactly what the values are going to be and what their types are, and it can therefore be a lot more efficient in how it allocates memory and lays out memory in the engine. So the actual C data structure used in the engine for an object is more efficient than the one for an array. And we see the results here. First time I published these results, someone else saw the article, tweeted it, and said, they replaced all object-like arrays with classes where they are used thousands of times. The memory usage was reduced 58% from 12 gigabytes to 5 gigabytes. What he's doing with PHP that requires 5 gigabytes of memory, I don't know. I don't want to know, but it's still way better than 12 gigabytes, no question. So I have a link here to the article if you want to see the full workup. So is there ever a good time to use an array in PHP? Yes. It's okay as an internal implementation detail. You kind of have to. At some level, if you have a list of things, there's going to be an array involved, but you're hiding it behind a real API. If you have something that requires an iterable, passing an array literal to it, that's fine. You know what you're getting there, and you can still use it the same way. If you want to call a method of an object or method of a static method of a class, you kind of have to use this syntax right now because PHP, its callables are terrible. Hopefully 8.1 will fix that. The vote to introduce partial function application was opened today. If that passes, we won't need that anymore in future versions starting 8.1. If you're doing dynamic named arguments as of PHP 8, then you can use an array for that along with variadics. And that's actually a really cool usage of them. More on that another time. And sometimes in generated code. There's a little quirk here. We said that classes are more efficient. That's true if it's a mutable value. However, if you have a constant array in a property of an object or in just a constant standalone, then that will use more memory than the equivalent object, but that memory is in shared memory. It's part of the code memory. And so that memory is used once and not reused by every single parallel process you have running. So if you have 5 PHP processes working at the same time, then those will not replicate the entire memory of that whole array. So it can be more efficient in that case, as long as you're careful to not accidentally copy them all back into memory when you process it. But note, we're still going to wrap the item up into an object to return it, so we get all of those API benefits as well. So this is an optimization you can take advantage of if you're generating out code or pre-building a lookup of some kind, but that's about it. So bottom line really is no, you should never use arrays in PHP, at least not in public where people can see you. Thank you. All right, so hope you enjoyed that. Before we go to questions, I'm going to raffle off a copy of Thinking Functionally in PHP. So the way we're going to do that, I just put a link to the book in chat. The way we're going to do that is I'm going to ask a trivia question, and whoever types the answer into the YouTube chat first, the correct answer, wins. And then just DM me on Twitter with an email address, and I can send you a link for a free copy. So the trivia question is, which one do I want to use here? The short array syntax using square brackets instead of the word array was introduced in what PHP version? What PHP version introduced the short array syntax?
That's a good one.
So when the stream catches up, whoever answers that first, let me know. In the meantime, if you want to see the book, the links in YouTube are not linking, but you can copy and paste them. If you want a copy of Exploring PHP 8, then there's a link for that. And DS got the right answer, PHP 5.4. Congratulations.
Congratulations.
So yeah, DM me on Twitter with your email address, and I will send you back a link. All right, with that, I'm happy to answer questions for as long as Barry lets me stay.
You're going to regret saying that. So, okay, so first of all, I just want to say that was an amazing talk. Thank you very much for that. And you have made me deeply worried about my sense of humor because I was laughing the entire way. I may need to go to some sort of doctor.
We can go to the same doctor.
Perfect.
Yeah. But which doctor?
Yes, the witch doctor. Perfect.
Yes.
Okay, so I do have so before we kick off, so I've got a question I'd like to open things with, and this is a very loaded one, or a very could have a lot of discussion here, but it's something I'm interested in. So,
all right, I'm ready.
Yes. So with I've worked in legacy PHP code bases, and array is the hammer for every nail. And so you constantly have the problem of passing around arrays, checking if the key exists, doing casting, et cetera, et cetera, et cetera. So I'm wondering if you have any high-level strategies, tactics and strategies for migration from A to B.
Funny you should ask, since I've been working on that kind of thing in Typo 3, because again, it's an older code base, so it has a lot of arrays that we're slowly working on. The first thing I will say is upgrade to PHP 8 for a couple of reasons. One, PHP 8 will catch everywhere that you have missing keys, because those are now warnings instead of notices. And it will force you to go through and deal with each of those cases. Now, deal with probably means just putting question mark, and a default value after everything, but that gives you a better sense of where you have gaps. Then, because you're on PHP 8 and you can require PHP 8, you can use union types. So you can type if you have a parameter that takes, let's say, an options array, or let's say an array for an order, to use that example. You can change the type hint to order pipe array. So it will accept either an order object or an array. And then inside the method, the very first thing you do is, if an array was passed, convert it to the object. And that convert logic should be a method on that object. Could be the constructor, could be a static factory method, up to you, whatever. But you convert it to an object. And at that point, you do all the checking to make sure the types are correct, the required values are there, and so on. You know, whatever you need to get it into a normalized, valid form. And if you can't, you error out right there because it's already wrong. And then you can redo the rest of the method to use that object exclusively. Potentially, you also then, if an array was passed, trigger an eDeprecated message, or whatever mechanism you want to use in your application to say, hey, caller, you're doing it wrong. You should probably update and use this object instead. And then once you are comfortable that you have given people enough warning, you remove the array option. Along the way, you can, that's the kind of straight approach. Along the way, you should be rethinking, do I even want this architecture in the first place? Can I take this options array and just refactor it entirely to something else? Sometimes the answer is just build a completely parallel system that's done right and throw deprecation warnings in the old one and then eventually delete the old one. That's a case-by-case question, and I fully anticipate having that conversation a lot in Typo 3 in the coming months for exactly that reason. So that's kind of at a very high level, the transition option that is probably easiest, because union types in PHP 8 give you that option. Before PHP 8, you would have to make everything untyped in order to do that, and that honestly makes it worse.
Yeah. Okay. Well, thanks for that. That makes perfect sense. So we actually have some questions here. So one is from the winner of our book. What would it take for us to get ext-ds into the core?
So for those not familiar with it, there was a PHP extension back in PHP 5 called XDS for data structures that tried to be essentially SPL done right and have a fixed length array that was way more efficient than the native arrays because it was technically an object. It had a stack and a queue and other structures like that that were not implemented stupidly the way that SPLs are. Most of the SPL's iterators are fine. Most of the data structure classes in SPL are horribly buggy and badly implemented, and you can't easily fix it. I don't know that that's even maintained anymore, and a lot of the performance difference changed in PHP 7. So arrays are more efficient in 7 than they were in 5 by a wide margin. They're still not as good as real objects. I think more likely, well, what's more likely to happen is eventually someone just builds those in core, and that will run into a fight about, do we wait for generics, which will stall it, and until and unless generics happen, it won't happen. That's kind of a depressing answer since generics are hard enough that they probably won't happen. But I think that's the most likely scenario. So sorry about that.
Well, if you just bring the word generics into the discussion, it's going to slow everything down.
Basically. Yeah, it's one of the challenges in PHP, that building truly generic list data structures kind of has to have generics in some way or be completely untyped. And we've learned our lesson that completely untyped is a bad idea, but we really don't have a good way of dealing with that at this point. The best option right now, honestly, is that for type static method trick that I showed before, which you can do yourself in user space. And it's essentially the same kind of thing as generics, just all in user space. And it's not great, but it's what we got.
Yeah. Well, you're just making do with the tools that we have.
Yeah.
Actually, I do have a question on that. So, one of the issues that can be with it, if you're extending the base types or implementing, it means you can't type hint or return type the particular type, but you can use a doc block for that. So it's kind of like it's not perfect, but it just means that your IDE will at least be able to look at it and understand what it's saying.
Yeah, doc blocks are better than nothing. My general statement is always document the type of a parameter or a property or a return, always, using the most enforcing option available. So, using the native types in the language if possible. If those don't give you enough expressiveness, then you put it into the doc block. And there's a lot of static analyzer tools like PHP Stan, Fan, other tools like that can read the doc block syntax and provide more robust type checking. So, for example, if you want an iterable of callables or an iterable of point objects or whatever, then in the language, you just say iterable. But in the doc block, you can say iterable of whatever. And then the static analysis tools can provide you with some additional help there. Nothing will happen at runtime, but it gives you some additional help.
Mm-hmm. Well, thanks for that. We have when we are talking about strategies for migration, Ken Guest asked, would using value objects be a good way to migrate or migrate at least some over the use of arrays?
Yes. Yeah, the bare minimum, I would say, is, as I said before, I'll allow the property to take array or value object, convert things to the value object and use that internally, and then drop the array option. And your time frame from that can be whatever you decide it is. Mm-hmm. Just don't make it forever, because then you have to support the arrays forever. So include the, if you want to do that transition, then including some mechanism to convince people or remind people that they do really need to change is a necessary part of that. That said, again, as of PHP 8 with constructor promotion and named arguments, that transition becomes way easier. And then you can use that to evaluate, okay, now that I've done that and that's cleaned up a lot of other code, now what can I improve? What can I refactor as a result? And that's going to be a case-by-case question. So yeah, even just moving struct arrays to struct objects is already a big win. And then you can figure out what else it makes sense to do after that.
Would you have any advice for people on or particular patterns? And Ken's kind of hinting at this here, and I'll ask this question afterwards. Smells with the way the array is being used that kind of lead you towards particular class structures? Or is it better to start off in a iterative, make a small change, turn to value objects, and then observe it again and go to a higher level and just let it tell you where it wants to go?
It's probably going to vary by the use case. So it depends, like always. In some cases, like I'll give a concrete example. When I was writing the product formatter example for the talk, I didn't know where I was going with it. I just threw that in on the first slide as, I know this is bad, let's refactor it. And then, all right, let's make that an object. What else can I do? Oh, that's right, I can put methods on it. Oh, I've got this, why am I not turning it around? So that part of the talk was actually me just writing bad code and then refactoring it as I looked at it, and each refactor was a new slide. That was how I did that. So in many cases, yes, just turning it into an object will suggest what the next step is. Other times you look at it and go, you know what? This whole approach is just fundamentally wrong. And this is a good opportunity to say, you know what? I'm going to carve out this chunk here and break the API on it because I have to, and just do that whole piece the right way. Because it's not just objects and arrays. Using arrays leads you towards certain styles of architecture, which usually are not that good to begin with. So if you want to rethink the style of architecture anyway, then go ahead and do the object conversion as part of that. And in that case, you carve out this chunk, not the whole system, you carve out this chunk and say, all right, what would be a better API for this chunk? All right, that design that new API, now figure out, okay, how do I get from one to the other? Which could involve value objects, could not, it probably does involve value objects somewhere, but they may or may not map to an previous array. Maybe you want to, you have an object that has 5 properties on it, all of which are big nested arrays. And you could just convert all of those to a tree of objects, or you could take the opportunity to say, you know what, this data is in the wrong place to begin with. You shouldn't have this deeply nested set of data structures. So I'm going to break it up to a different object in a different fashion that holds less data or is separate, or whatever makes sense in that use case, possibly with some kind of bridging code, if possible. And if possible is going to vary on your specific use case, what API guarantees you have, and so on.
Okay, great. Thanks. Okay, so we've got 3 questions here from Ken. He's really slacking today. Usually many more. So first is he's asking Larry if you are planning on writing a book on not using arrays anymore.
I already wrote an article for PHP Architect last year. That's basically the written version of this talk. I don't know that there's a full book in it. However, I suspect if I do a second version of Thinking Functionally, which I will do if enough things get into PHP 8.1 to justify it, that will also serve as, here's a lot of things doing, handling lists in a functional style, which is a lot better than procedural in most cases. So that'll touch on similar topics. And in the current version, I also talk about data modeling some, although it's not the focus. But I will consider it if I can come up with a way to do it longer than a single article, because I've already done that.
A suggestion, if you threw in the examples of migration strategies, I'm sure that people would be happy with that, because I'd say that's a common problem.
Quite possibly.
Just my 2 cents. Okay, so Ken's got another question.
Thank you for giving me ideas.
No problem. So my usual cut is 10%. So we can discuss that after. I'll get my law person. Yeah, I know the technical terms. They'll get in contact. So another question from Ken. Is there any one static analysis tool that would you consider having the edge over others in detecting sections of code that should be changed from using arrays, or is it ecumenical and context specific?
I have not personally reviewed the various static analysis tools. My understanding from people who do use them a lot more than I do is the 2 big ones are PHP Stan and Psalm, and both have places where they are better than the other. So there are some projects that use both. Personally, I would say use whichever one you feel more comfortable with, and use an IDE that will do a lot of it for you just as you're typing. In practice, I personally mostly rely on my IDE to catch things. On Typo 3, we use PHP Stan set to, I'm not sure how strict it is at a fairly pedantic level. And we'll also check things like code style, making sure you're using PSR2 or 12 and stuff like that. So I'm not going to endorse any particular one. They all have benefits. Using multiple is not a bad thing.
Okay, great. More questions, so just keep going. So what do you think of the immutable iteratable RFC?
So for those not familiar with that, that's an RFC currently in voting for PHP 8.1 that creates an iterable class that is designed to, you pass it another iterable and it runs out the whole iterable and materializes it, and then provides an immutable copy of it that you can then do stuff on. I'm probably voting against it, not because I'm against the principle, but because the specific implementation has a lot of other stuff on it around serialization and handling of pairs, which is a concept that I've never seen anyone use in PHP. So I'm not a fan of it for that reason. Data structures that provide better list handling and more reliable list handling in general, I'm cool with. This particular one, I was a bit torn. It does have performance benefits, but I'm kind of on the interface for it. So I'm probably voting no on that.
Okay. Well, that makes sense to me. So let's see, 2 more questions. And then I think that's, nope, 3 more questions. So let's see, for one here. What do you think of the, let's see, what do you think of the slow burning thought of there being a PHP foundation that would/could support Fig and user groups along with fund gathering for paying core developers?
controversial, but damn it, we need it. It's tricky. I've seen different communities do it different ways, some better than others. A lot of it comes down to the culture of a given community. PHP internal specifically is vehemently flat and vehemently egalitarian. I shouldn't say egalitarian. It's vehemently structureless, which is not a good thing, but it is a thing. I do think having a pot of money to stably fund PHP development is a good thing. However, given the nature of PHP, that then runs into fun questions of who controls that money and who decides what it's spent on and who it's spent on. And if money is spent on a given feature, does that mean it has to go in? Right now, I think the only person paid to work on PHP full-time is Nikita Popov, whose day job at JetBrains is go make PHP better. That's his job description. And we are immensely blessed that they are doing so, because Nikita is fantastic. PHP would be nowhere near as cool a language. I mean, he alone was responsible for like a third of the coolness in PHP 8.
We are all very grateful.
Yeah. So that is fantastic. I would love to see more companies doing that. I will say I've been doing some work on PHP 8 kind of on behalf of Typo 3, because the 8.1, because the 8.1 is probably what we're using for our next version. So functionality to get into that is functionality we're going to benefit from. That's not technically my job description, but I view it as a part of making Typo 3 better includes make PHP better. I would love to see more projects that are built on PHP do something like that, and just assume that working on PHP is part of working on their project. Yeah, there's a lot of cultural logistics that are more important than the financial logistics for that.
Yeah, yes.
I would love to see those dealt with, but that's going to be, refactoring culture is harder than refactoring code. So I don't know what will happen with that.
Well, if you figure out the answer to it, please let us all know.
I'd love to.
So they've got a question here from Ram, and he's asking about, further to the question asked earlier, transition of nested data structure or array structures. Is there a good way to allow, and the example here is an object of foo, and then indexing to that by bar, and then indexing to that by baz in array access?
If you have offset get returned by reference, then I think that works. I've not tested that in a long time, so I might be wrong, but I think that would allow you to do that. That said, if you have that, it's a surefire sign you really need to refactor quickly, because except for some very specific cases, that is something that desperately needs to be proper objects, and that's the first place you should start, frankly, with proper objects. But yeah, I think returning by reference would let you support that as a transition.
Okay, great, fantastic. And I think there's one more question here, and this is from Ken and myself. When will you be giving your next talk at PHP Dublin? Just put you on the spot, that seems fair.
Yeah, that's up to Barry. I happy to talk about other topics as well. Let me know. I can talk about PHP or management, and hopefully for 8.1, I will have a couple of new talks for that. So you can get all kinds of new content in a year.
Excellent. Oh, okay.
Like 6 months.
I am going to be watching the news like a hawk and then sending a DM immediately afterwards. Well, okay. I think that's everything. I think we've answered all the questions, and I could probably make up more questions, but we've taken up enough of your time. Thank you so much for coming here, Larry, and taking time to give an excellent talk. Just one thing I've noted here is that you are very good at encapsulation and evolution of designs. So that was very clear from that talk. I know it wasn't intentional, but it's always nice to see that.
That's great feedback. Thank you.
Pleasure. And thank you for the questions, for answering so many questions. And I would like to say to everyone that's watching, thank you for attending. PHP Dublin is nothing without people joining and asking questions and being involved. And if you or anyone you know would be interested in giving a talk or discussing a topic, feel free to reach out to us and we can make that happen. So I think without further ado, finish off. Larry, thank you very much.
Okay. Thank you.
Okay, best of luck, everyone. And the stream is over.